Assalamualaikum and good morning everyone. So today we are going to continue our lecture with the topic of social behaviors. Okay, before that let me share my screen. Okay, I hope that all of you can see my slide. Alright. Okay, so for today, we are going to continue our subtopic in the topic of social behavior with the other five subtopic, which is calculation of R, B and C, reciprocal altruisms, kin discriminations and selections, and also spike and cooperation. And the last subtopic is the evolution of eusociality. Okay, so in the previous lecture, we already studied about the Hamilton's rule. Okay, so the rules is actually when the benefit from helping a relative reduced by the degree of relatedness is greater than the cost. Okay, the Hamilton proposed a quantitative measure to predicting when natural selection would favor altruistic acts among the related individuals. Okay, so and again the altruistic is the sorry, the disadvantage to the actor to itself, but it actually benefits to others. Okay, and the others is often to its close relative. Okay, so there are three key variables in an altruistic act. The first one is the benefit to the recipient. The second one is the cost to the altruistic, and the third one is the coefficient of relatedness, or we call as R, the fraction of genes that on average are shared. Okay, we call as R. So okay, let's we recall back. Okay, so this is altruisms and one call. Okay, if the actor get the harm, okay, and the recipients get the benefits. So what does it call? Okay, so it's actually acts altruistically. Okay, which is it give the advantage to itself, okay, to the actor, but it give the benefits to the others and often to its close relatives. So we call it as a acts out truly acts altruistically. Okay, I sorry. Okay, so how about this? Okay, how about if the actor does not give a call, and of course it can give the benefit to itself, okay, because it don't attract the predator to itself, and the rest of the colleague, okay, the rest of the members get the harms. Okay, so what does it call? So it called act selfishly. Okay, so actually the altruistic is the advantage of the action is the disadvantage to itself, but it gives the benefits to others. So you call it altruistically. Okay. So this is the Hamilton's rules. Okay, where the theory of kin selection, the inclusive fitness, discounted by the coefficient of relatedness between the actor and also the recipients. Okay, so BR must be larger than the C. So whereas the C is the fitness cost to the individuals that performing the behavior, the actor. Okay, so the fitness cost. All right. So the fitness cost is actually we categorize it as the survival rate or the reproductive success. So we call it as a fitness. So the cost to the fitness we call it to the individual performing the behavior, the actor. So B is the sum benefit to all individuals affected by the behavior. And the R is the average coefficient of relatedness between the actor and also the recipients. Okay, the relatedness between the actor and also the recipients. So we call it as a R. So, the Hamilton's rules is illustrated with the following examples of the female who risks her life to save her brother or to save her kid. Okay, so this is the situation. For example, so we assume that the average of individuals has two children or offspring. We assume that the average of either the female or the brother, the kids, might have two children or offspring. So, as a result of the female actions, which is the female risks her life to save her brother. So, as a result of the female actions, so the brother cannot be a father of two children or two offsprings. So, B, the benefit is two, right? So the females or the sister of the brother, so the female has 25% chance of dying and not be able to have the two children or offspring. So the cost to the actor is 0.25 times by 2, and we got the C is 0.5. So the brother and the sister share half their genes on the average. So R is 0.5. So R is 0.5 is because the parents are contribute half their genes to each offspring. So the probability that genes are identical by the descent for each step we call as a 50% or 0.5. Okay. So if the females or the sisters save her brother, so this situation if the female save the brother, so RB is equal to 1. Okay, which is 0.5 times by 2 equal to 1 is larger than C. C is 0.5. So it is actually agreed with the Hamilton rules, which is the benefit from helping a relative, okay, which is the benefit of female helping the brother and reduced by the degree of relatedness is greater than the cost. Okay, so this is altruisms. Okay, acts altruistically. Okay, it helps it helps the closely related, okay, which is it gives the benefit to the recipients but it gives the disadvantage to itself. Okay. Okay, so we have done with the calculation of RBC. So we go to the reciprocal altruisms. Okay, so in the previous lecture, I already mentioned a little bit about the reciprocal altruisms. So the altruistic behavior towards the unrelated individuals can be adaptive if the aided that helps individuals, okay, returns the favor in the future. Alright, so this is we call as the reciprocal altruisms. Okay, so this is actually the second major way in which altruisms can be favored is if the recipients repay altruistic behavior in the future. Okay, so which is the actor is give the benefit, help the benefits to the unrelated individual. So we call as the reciprocal altruisms. Then that individuals will repay back the altruistic behavior in the future. Okay, so this is reciprocal altruisms. So some animals occasionally behave altruistically towards non-relative. It behave altruistically, which is give the benefit to the others and may have the disadvantage to itself, but towards the non-relative. We call as a reciprocal altruisms. And this reciprocal altruism most likely in social animals where individuals interact repeatedly because they are long life and form a groups, okay, and also when individuals have a good memories. Okay, so this is the factor why the uh, the reciprocal altruism most likely in a social animals. Okay, so for example in here, okay, we're talking about the vampire bats. Okay, we take the vampire bats as examples in the for the reciprocal altruisms. Okay, so the vampire bats feed on blood and share communal rules. Okay, so this is the situation where the vampire bats are feed on blood and there are shared communal rules. Okay, but bats may starve if they fail to feed several nights in a row. Okay, so they must feed at least one night. Okay, if not they will fail if they don't have if they fail to if not they will starve if they fail to feed several nights in a row. Okay, direct that hari they didn't get the blood, so it will starve. So however bats who have fed successfully often regurgitate the blood meals for unsuccessful bats. Okay. So the successful bats, the bats that get the bloods, okay, they are often regurgitate the blood meals for the unsuccessful bats. They helps the unsuccessful bats to get the blood. Okay. So it costs sharing some blood is relatively low, okay, because they already fed the blood. Okay, so the cost of sharing the same blood is relatively low. Okay, so the donor for the donor, but very valuable for the recipients. Okay, so the costs are very low for the donor, but it's very valuable for the recipients. And some research shows that the vampire bats are shared with relatives, but also share with individuals who have shared with them previously and with whom they usually share a roof. Okay, so it's actually um the vampire bats also will share the will share the blood to the to them who previously shared the blood to him. Okay, which is he returns the favor in the future. Okay, and also with whom we usually share a roost, even though they are not related. Okay, they are not have the close relations. Okay, so that is the reciprocal altruisms. Okay, we take the examples of vampire bat. So we move to the third subtopic, which is kin discriminations and kin selection. Okay, so for the kin selection, so is the natural selection that favor this kind of altruistic behavior by enhancing the reproductive success of relative. Uh, so this is we call it as kin selection. Okay, so the natural selection favoring the spread of allele that increase the indirect component of the fitness. Okay, fitness we call as the survival rates or the reproductive success. Okay, and examples of kin selection and altruism is the warning behavior in the buildings ground squirrels. So in a group, most of the female are closely related to each other. Okay, in the group of the building ground squirrel, most of the female are closely related to each other, and most alarm calls are given by the females who are likely adding close related, who are likely help their close relative. Okay, so as you can see from this graph, so the kin selection and altruism in Belgium's ground squirrels. So this is the mean distance moved from the birthplace. So as you can see from here, the female are normally remain to their birthplace. Okay, it different with the male. So the males starting from the age of 3 months, they already move from the birthplace. This is why we're talking about the females are closely related to each other, right? So giving alarm calls alert other individuals, but may attract a predator's situations. Okay, it will give the disadvantage to the um individuals that give the alarm call. So the building ground squirrel give two different calls depending on whether predator is a predator mammal or a hawk. Okay, so if the predator is a mammal, so the Belgian ground squirrel will give a call of thrill. Okay, but while the if the predator is a hawk, so it will give an alarm call as a whistle. So they have two different calls. Okay, so this is an experiment done by the Sherman and the colleagues. Okay, so they observed 256 natural predator attacks. Okay, so in predatory mammals attack, so the trailing squirrel is killed 8% itself. Okay, the squirrel that give the alarm call, the trailing alarm call, will kill 8% of the time, and non-trailing squirrel is killed 4% of the time. Okay, so this calling squirrel does appear to increase its risk of predations because it have higher percent of killing. okay, compared to the non-trilling squirrel, okay. And in the hawk attacks, okay, the whistling squirrel, the squirrel that give the whistling alarm, okay, is killed 2% if they give the alarm, okay, of the time whereas the non-whistling squirrel are killed 28% of the time. So the calling squirrel appears to reduce its chance of being killed, okay. So if the whistling squirrel saw a hawk, so they will give the alarm call, okay, because it will reduce the chance of being killing, but it will increase the chance of being killing for the rest of the members. So the whistling appears to be selfish, okay, because they will give more chance to be killed by the predator to the uh, to, to their members, okay, compared to itself. So we call the whistling appears to be selfish, but the trilling squirrel, okay, it appears to be altruistic. This is about the kin selection. It help their own relative, okay. So buildings ground squirrel breed in colonies in alpine meadows. So male disperse, but female offspring tend to remain and breed close by. Thus, the females in colony tend to be related. Okay, we are talking about the graph just now. Okay, so the male are already dispersed. Okay, when starting 3 months. Okay, while the female they are remained in the birthplace. So the female in colony tend to be related, okay. And the Sherman, okay, had marked animals and had pedigrees that shows relatedness among study animals, okay. So the analysis of who called showed that the females were much more likely to call than males, okay. So this is another experiment by the Sherman and the colleagues. So as you can see from this bar chart, okay, so this is the frequency of alarm call. So the blue line is the expected from the Sherman and the colleagues. Okay, they expected that this is the degree of adult female that give the alarm call. This is the degree of adult male to give the alarm calls, and the bar itself, the brown bar is actually the observed result. So as you can see from this bar chart, so the adult female give the most alarm call compared to the adult males. And even though 1 year females give more alarm call compared to the adult males. And it also surprisingly shows that the juvenile females of the ground squirrel give more alarm call compared to the 1 year males. Okay. So it shows that the females are more likely to call than males. Okay, so it actually tend to be help their relative. Okay, so in addition, female more likely to call when they had relative within their earshot. Okay, so the relative also cooperated in behaviors beside alarm call. They also cooperated, okay, which is the female were much more likely to join close relative in chasing away trespassing ground squirrels than less closely related kin and non-kin. So they are also the kin or the relative are also help the female that give the alarm call by chasing away the predator. Okay, so in order for there to be kin selection to know which is their relative, okay, animals should have some mechanism to recognize their kin. So how might this occur? All right. So we move to the kin discrimination. Okay, so just now is the kin selection. So how does the animal know that particular individuals is their kin? So this is we call as a kin discrimination. So we have three mechanisms. Okay, the first one is the green beard allele. So this is the recognition allele that expresses itself phenotypically. Okay, so and enabling those possessing the gene to recognize that gene in others. Okay, so phenotypically is the observable physical or biochemical characteristic of an organisms, okay, as determined by both either the genetic makeup and environmental influences. So it appeal it can be observed physically and biochemically, all right, the gene expressed, okay. So a single allele that causes the signal, it can cause the signal, causes it to be recognized in others, okay. The allele, it cause a signal, okay, apa tu, cause a signal physically, and also can cause to be recognized in other by the biochemical characteristics, and also that allele can produce cooperative behavior. So this is the first mechanisms how the animals can have the discrimination towards their relative, the green beard allele. So, and most green beard allele are in microbes, okay, but one is in fire ants, which is GP9 locus. Okay, so this is the green beard allele in the fire ants. Okay, so the new queens recruit into the nest after the dominant queen mate. Okay, and how then the workers will with a B allele at the G9 locus use the order to determine if the recruiting queens, okay, the new queens recruit just now possess the allele, okay, possess the allele of their kin, and kill them if they don't, okay, if they don't possess the allele of their kin, their relative. So this is how the workers discriminate the new queens, okay, by using the Gambit allele. So the second method to discriminate the kin is using the genetic kin discrimination, which is shared gene are recognized phenotypically. Okay, so the chemical cues, they can also use the chemical cues or others be altruistic to neighbors who smell like you, or we call unpick effect. So they sometimes use the chemical cues or others to recognize their own kin. And the third method or the third mechanisms to discriminate their own kin is using the environmental cues, which is the simple rules. Treat anyone at home as your kin. Okay. Um, or they also use learning or imprinting, so they will learn how to treat their relative, okay. So or and the learning behavior is we call imprinting, one category of behavior imprinting, okay. So for example, in here, building ground squirrels. So the third mechanism is by using the environmental cues, which is learning or imprinting, right? So the example here is building ground squirrels. So they recognize kin by learning. So unrelated ground squirrel raised together are not strictly aggressively. So even though they are not related, okay, they are not share the same gene, they are not share the same father mother, but if they are raised together, so they are not treated aggressively, okay. So so there is also phenotype matching amongst the females, and also the odors from the squirrel glands, okay, from the squirrel glands also give a cues of relatedness, all right. So we already done with the kin discrimination and selections. So we go to the spike and cooperation. So spike, okay, spike in Hamilton rules also show that the natural selection can favor spiteful harming behavior. So spike in the previous lecture we were talking about both get harm, all right, both harm. Okay, both harm. Macam mana? So spite is favor when it is directed at non-relative, and spiteful behavior frees up resources for relative of the actor. Alright. So in some warps, the larvae develop soldiers to attack other larvae. Okay, for example, female soldier larvae will attack brother larvae to free up the resources for other females. Okay, but both get harms. Okay, either the female soldier larvae and also to the brother larvae. Okay, so only spiteful if behavior is really costly and does not give some benefit. Okay, because of soldier larvae are not reproductive. Okay, and the second one, the situation is can cause spiteful if the harming behaviors are directed towards relatively unrelated individual. So the soldier professionally attack larvae to which they are less related. Okay, and the third one, there is strong competition for local resources and variability in relatedness. So this is the situation happen. If this three situation happen, it might cause a spiteful, which is both are get harm. Okay. Okay, that is the spike. And we go to the cooperation. So, but what about those animals that cooperate that are not akin? Okay, they have the cooperation, but both are not akin. So, how do we explain them? Okay, so cooperation, a behavior is cooperative if it provides a benefit to another individual and has been selected for because of its benefit to the recipient. So the actor get the benefit and the recipient also get the benefit, but both they are not have related each other. Okay. So why should an individual carry a behavior that benefit another individuals? Okay, so especially if that the cooperation is cheated. Uh, we call as the prisoner's dilemma. So this is the prisoner's dilemma. Okay, this figure shows that the fitness payoff for the player A in prisoner's dilemma. So this is the example of situations. Okay, so in this game, two crime suspects are being interrogated in separate rooms. Okay, so there is enough evidence to guarantee a short jail sentence for each of them, for each of the two crime suspects. But each is offered a deal. Okay, complete freedom for squealing on the other one. So each of them, each of the crime suspect, they are offered a deal, which is complete freedom for squealing on the other one. If each inform on the other, however, they both serve an intermediate jail sentence. Okay. With this payoff, the reciprocal altruism can evolve only if the individual have repeated encounters. In that case, the tit for tat strategy, okay, which instruct each player to cooperate on the first move and then do whatever the opponent did on the previous move. Okay, so it an evolutionary stable strategy. So we call, just now we are talking about the in the previous study, ESS, which is it instruct each player to cooperate on the first move, then do whatever the opponent did. So we also call it the ESS here. So the situation is, okay, if both prisoners stay silent, okay, if the prisoner B and also the prisoner A silence, so which means both are cooperate. So both will reward for mutual cooperation. Both get the rewards, which is only serve 1 year in prison. But if the prisoner A is betrays and the prisoner B is still silence, which is give the cooperation. Okay, so which means that the prisoner A are defeats. Okay, to the offered. Okay, so the prisoner B will get the prisoner A will get maximum reward. Okay, which is the prisoner A will goes free, but the prisoner B will get 3 years of prison. Okay, under the bars. So if same goes, if the prisoner B are betrays, okay, while the prisoner A is cooperates. So the prisoner A will get maximum punishment, which is the prisoner A will get 3 years and the prisoner B will goes free. But if both are betrayed, both are defeat to the offered, okay, so both get served 2 years. Compare, if they both give the cooperation, they will get only 1 year in the jail. Okay, so this is what we call as a tit for tat strategy. It is hard for them to cooperate. Okay, especially when the occupation is cheated. So, the president dilemma is an illustration on how difficult a problem cooperation is. So, it is difficult for the organism, for the animals to cooperate. Okay, so that is the dilemma. So, both individuals will benefit from mutual cooperation, okay, but both are tempted to cheat. So, cooperation is not necessarily an ESS because a mutant cheater can spread. Okay, so we are already done with the spy and cooperation. So we move to the evolution of eusociality. In the previous study, we already talking about the eusociality, but here we are studying about the evolution of the eusociality. So, as you still remember, the eusociality is the cooperation of individuals in a group to raise the young, right? So the youth society also we call as the true sociality, which is they cooperate, okay? They cooperate in the group to raise the young, any young. So many youth social insects, for example, bees and termites, they do not produce because they are give their life to help others to raise the young. So instead, they act as a helpers at parent nest for their entire life. So they do not produce because they act as a helpers. Alright. So in eusocial species, some individuals forego reproduction to aid in the rearing of others, and most common in the Hymenoptera. For example, ants, bees, and wasps. Okay, they forego their reproduction in order to help their parents to rear the others. So they have three characteristics of eusociality. The first one is the overlapping generations of parents and their offspring. Okay, they are if they have the overlapping generations. Okay, the parents the parent produce the young. Okay, so they still have the younger offspring, so they will have the overlapping generations. And the second characteristic of eusociality is cooperative brood care. They cooperate to have the brood care. And the third one, specialized caste of non-reproductive workers. In especially in the group of Hymenoptera, for example, they have a caste. Okay, they have a caste. So this is the caste in the Hymenoptera. Okay, why should eusociality be so common in the Hymenoptera? Okay, you can see from the size of the Hymenoptera, the worker are very sterile and very small compared to the drone and also the queen. That is why the worker are being a worker. Okay, they help the queen and also they help the other to raise the young. Okay, and they're not reproductive. And why should eusociality be so common in the Hymenoptera? So the Hamilton, again, these guys suggested it was due to the haplodiploidy. Okay, haplodiploidy. So this is the factor that suggested by the Hamilton, okay, to the eusociality. Okay, so because of the female developed from fertilized egg, diploid, okay, the female are diploid, and males develop from unfertilized egg. So male are haploid. And one idea advanced to explain the eusociality in unusual genetic system, which is the haplodiploidy. Okay, so this is unusual genetic systems of the Hymenoptera. Okay, so males are haploid and female are diploid. So male develop from unfertilized egg. That is why male is haploid, and the female develop from the fertilized egg. That is why female are diploid. So this is the unusual genetic system, the haplodiploidy. So this haplodiploidy explain why it is eusociality in the Hymenoptera. The daughters receive all of their father's gene and half of their mother's genes. Thus, the daughters share three quarter of their genes. Okay, so this suggests that the female would be better off if they favored the production of reproductive sister rather than their own offspring. Okay, why it would say like that? Okay, because the sister will get half of the mother and one whole of the father, and the brother only get half from the mother. So in the haplodiploidy system, the sister and the sister comparison, so the degree of relatedness, they have three quarter. Okay, so they have bigger degree of relatedness. So half of the female's genes come from the father, and probability that a copy of one of this is shared by with the sister is one. Okay, the probability of shared the gene by the sister is one. So that is this is the rules, the Hamilton rules. Okay, they just put in the numbers here. So the relatedness, the coefficient relatedness of the sister is three quarter bigger. Okay, they have a bigger coefficient of relatedness. So the degree of relatedness, mother-daughter. Okay, so if diploid is half and the haplodiploid also half. Okay, so it seems the diploid also half, the haplodiploid system also half. And if the sister brother relations, so they diploid half, but the haplodiploid system, they only have quarter. They only share quarter of relatedness. Okay, on sister brother. And okay, here is the because of the brother only receive the gene from the mother. Okay. Okay, so the inclusive fitness of female workers is higher if they can help produce more sister. Okay, because they have more related. Okay, the degree of relatedness are higher. Okay, so the inclusive fitness the inclusive fitness is the relative reproductive success of a gene in an individuals. Okay, plus all the close relative. So this is why the workers is higher if they help produce more sister. The inclusive fitness. So, does hyperdiploidy explain the evolution of eusociality? Okay. Does the hyperdiploidy only the factor that explain the evolution of eusociality? So the answer is no, because many colonies in EU social species are founded by more than one queen. So more than one queen, not only one queen. So the workers in those colony can have zero relatedness. And the second reason is because many social colonies have more than one father. So the average R, coefficient of relatedness among the workers, is far below than the three quarter. And the third reason why not only the haplodiploidy become the factor of evolution of EU sociality is because of many social species are not hyperdiploid, and not all hyperdiploids are eusocial. For example, we have termite. Termite is diploid. Okay, they don't have hyperdiploid, but the termite are eusocial. Okay, so this is the phylogeny of the Hymenoptera, as you can see from here. So the eusociality evolved in group that build compact nests and that care for their young ones for extended period. Okay, as you can see from here, so there is no evolution in here. The evolution start evolve in a group that build compact nests. Okay, and that care for their young ones for extended period. So, for examples of eusocial mammals, okay, is the naked mole rat. So this is the naked mole rat. Okay, so this is the figure of naked mole rat. So the behavior of naked mole rat is similar to that termites. Okay, they are diploid. Okay, so they are not haplodiploid, but they are also sorry, but they are also uh, eusociality groups. Okay, so unlike termites, both males and females are diploid. Okay, unlike the Hymenoptera, they are haplodiploid. So the colony of mole rats may include as many as 200 individuals, but there is only a single reproductive female and only 1 to 3 reproductive male. The rest, they are not produced. Okay, so remaining individuals are acts as workers, and they dig tunnels for finer food. They defend the tunnel system from the other more rats, okay, from the other colony, and also they tend the young. So this is the function of the workers. Only one single reproductive female and 1 to 3 reproductive female in one colony. Okay, that involve of 200, as many as 200 individuals. And the leading hypothesis for why naked mole rats are social is inbreeding. So beside the experiment done by the Hamiltons that suggested that the eusocial is actually because of the hypodiploid, but the naked mole rat situations, it suggests that it is because of the inbreeding. Okay, so inbreeding is the productions of offspring from the mating or breeding of animals or organisms that are closely related genetically. So the other reasons of eusocial is inbreeding. So average coefficient of relatedness is 0.81, and about 85% of mating are between their own parents and offspring or between the full sibling. So this is result to inbreeding in the naked mole rat. So despite they have the high level of relatedness because the mating are between parents and offspring, the mating are between the full siblings. So despite of they are having the high level of relatedness, conflicts still occur because the reproductive interests of workers and the reproductive are not identical. Okay, so the queens are maintained control through the physical dominance. Okay, so the queen aggressively shove the workers who do not work hard enough, and shove are mainly directly towards less closely related individuals, and the workers will double up their work weight after being shoved. So in addition to inbreeding, okay, beside the inbreeding, the ecological factors such as severely limited alternative breeding opportunities and also group defense appear to contribute to eusociality in naked mole rat. Okay, so actually the factor that contributing to evolution of eusociality in animals, uh, the first one is nesting behavior. Okay, for example, compact nest with prolonged care for young one, and also inbreeding in the naked mole rats, which is lead to very high relatedness coefficient, and also the factor of group defense against the predation will also contribute to the evolution of youth sociality, and also severely constrained breeding opportunities also contributes to the evolution of youth sociality, not only hypodiploidy that's suggested by the Hamiltons. Okay, so we end of our slide, our class for today. So normally for so basically for this class, we are talking about the calculations of R, B, and C. Okay, we are also studying about the reciprocal altruisms. Okay, the actor that gives benefits to the recipients that not related to itself. Okay, we also study about the kin discriminations. Okay, how to discriminate their kin is by 3 mechanisms. Okay, we just refresh back. The first one is the green bed allele. Okay, the second one is the genetic kin discrimination. conditions, okay, and the third mechanism for the animals to discriminate their own kins is by the environment's cues, by order, something like that, okay. We also learned today is about spite, okay, it's about spite, which is both get harmed, and also we also study about the cooperation, how hard to cooperate each other, okay, if there is also a cheat possibility, and also the last topic we are studying about the evolution of EU sociality, which is we also have the other four factors rather than only hypodiploidy that give the factor of EU sociality in animals. All right. So I think that's all for this week. Okay, I'll see you next week. So we will have tests. Okay, so please prepare yourself from lecture 1 to this lecture 5. Okay, if you guys have any questions regarding our topic, any topic, you can just WhatsApp me. All right. Thank you very much. I'll see you soon. Okay. Assalamualaikum.